So we're now going to talk a little bit about data types in Python. There's not much that we need to know at this point, but here are some things just to acquaint you with the concept. So we've already seen the most simple data type, or the most natural one for us. That's the integer. So if I create a variable a here, I assign it the value 2, then Python, in addition to creating a space in the memory and letting us access it by using the name a, he also makes a note that a is to be interpreted as an integer, meaning that if we multiply by it or add by it, Python tries to add by an integer. A close cousin of the integers are the floating point numbers. So this is the way that Python stores non-integer real numbers, like a third. Now this concept is, or this data type is a bit more complicated. And this is because some real numbers have infinitely long decimal representations. And Python cannot store an infinite number or infinite amount of information. Now, this number here is seemingly innocent, so it has 0.3333. And then what happens is that Python needs a clever way to store this. So we're going to discuss the details of this in a later film, but just note that there's a fundamental difference in how a computer stores integers and floating point numbers. So let's move on to another data type. So let's see what happens if I do this square brackets and 2. Now, this is a sort of a silly example, but now I'm creating a list containing just the number 2, and I'm giving it the name C. So if I print C now, well, you'll get 2 with the brackets. And what I can do now is I can put more things in my list, so a lot of numbers. I can put B, my floating point number, or I can put a string, hello. So now I'm having 2, 3, 1, this thing here, and a string of text that's string hello. So that's kind of silly. Now, just as with integers and floats, Python here reserves a space in the memory. We can access it by using the name C. And then whenever we access it, we obtain, or we get to this list. And there are a lot of things you can do with lists. And the point here is that it's not to go into the details of this just yet, that's in another film, but just to know that whenever we try to do stuff with C now, then Python will understand that we're trying to do stuff with a list. So let's just take one example. What happens if we create D to be C multiplied by 2? Now, if C was an integer, there would be no mystery. But now we're multiplying a list by 2. So now Python has to think a little bit, okay? So he looks up, okay, what am I supposed to do when someone tries to multiply a list by 2? This is why you have data types, so Python can kind of look up and try to figure out what to do with that content. And lo and behold, if I print D, then I get here my list twice. And if I do the list multiplied by 3, I get everything 3 times. What happens if I try to divide a list by 2? Well, Python crashes, okay? So for lists, there is no concept of division, but there is a concept of multiplication. And clearly, what happens if I add C with C? Well, it's the same as if I multiply by 2. And finally, there's one last data type we're going to be using. It's a bit more advanced than these data types. We need to use an external package first. And external packages are basically easy to use because most come with your Python installation. So you just here need to write import and then whatever it is that you're supposed to import. And now we're going to import NumPy, which is numerical Python. And then if you import just NumPy, then you have to write NumPy. And then we give NumPy a short name here. So whenever we want to use NumPy, we just put NP. So this is very standard. So now I want to create, well, I can create E here. So let's just do a list first. So I'll do a list 2, 3, 4. Now this is just a list of numbers. And we perhaps would like to look at this as a sequence. And in mathematics, when you multiply a sequence by 2, you really would want to multiply each term by 2. So the result of this sequence multiplied by 2 ought to be the sequence 4, 6, 8. But if I multiply this list by 2, I'm just getting 2, 3, 4, 2, 3, 4. So Python has a specific type of list called a NumPy array, which is very suitable when your list just contains numbers. So your list can contain just integers or just floats or a mix. And now I create my f here, and then I use the command np. So now I'm using a command from NumPy. And to get the commands inside of NumPy, I have to write np dot, and then I put array here. So now I'm converting E to this NumPy array, and I'm storing the result as f. So I can print f here. and then we get this 2, 3, 4. So if I print E, let's see if there's a difference. I get 2, 3, 4. So you can see here the difference is very subtle in the type of output you get. So if you want to be more, if you're really wondering what data type my variable has, I can use the command type. So if I write type E here, Python will tell me what the type is, or rather he will determine what the type is. But for Python to show it to us, we need to print what the type is. So here E is a list, so class list, and F is a NumPy ND array. So we call it a NumPy array. And what's the point of using this NumPy array? Well, E, F, G, so I can take my F and multiply it by 2, and then I can see what the result is. Is it just the list being repeated, or do I get each term multiplied by 2? Yes, I get each term multiplied by 2. So depending on what you want from your list, so to speak, you should assign it different data types. So if you just want a grocery list, where multiplying it by 2 is, well, repeating everything, just use the list. Or if you want a vector or a sequence of numbers for which you have a specific notion of what you want arithmetic to mean, then use a NumPy, or then you could use a NumPy array if this is what suits you. So more details on each data type later.